Video, we would like to derive an equation for the beat frequency. So, before going to that, let me tell you quickly what do you mean by beats. When two waves of slightly different frequencies traveling in the same direction are combined, there is a production of alternate waxing and waning, that's maximum and minimum frequencies. That phenomena is called beats. When I say two waves, you can express them in terms of displacement. So, y1 equal to a sine omega 1t. Omega 1 is its respective angular velocity, so it has a frequency n1. Y2 can be written like same amplitude traveling in the same direction but with slightly different frequencies. I may assume that omega 1 and omega 2 are very close to each other. When they were combined each other, y resultant will be y1 plus y2. So that's y result. That y resultant can be written like a can be taken like common sine omega 1t plus sine omega 2t. This is sin c plus sin d. We have a formula sin c plus sin d as 2 sin c plus d by 2 and cos c minus d by 2. Let us just apply this formula to get resultant here. That implies y resultant is a is there. I'll get a 2 extra cos c minus d by 2, that is omega 1 minus omega 2 by 2 and t, and sin c plus d by 2 sin omega 1 plus omega 2 by 2 into t. This resultant, if you notice carefully, is also a equation for the wave but having a resultant amplitude differently. So I can write y resultant as a resultant of sin of omega 1 plus omega 2 by 2 into t, which is also a wave format where the resultant amplitude of both the waves is 2a cos omega 1 minus omega 2 by 2 into t. This is the y resultant. Displacement is maximum, right? If you want to calculate the intensity of that wave, intensity is some constant k into square of amplitude. So I will get intensity proportional to 4a square cos square of omega 1 minus omega 2 by 2 into t. That's if that intensity is maximum. If intensity is maximum, you call that as waxing. So for that intensity to becomes maximum, this cos square of that function, cos square of omega 1 minus omega 2 by 2 into t has to become maximum. That implies cos of that cos maximum is equal to 1. So cos of that value, if I take a square root on both the sides, is square root of 1, that is also plus or minus 1. So this part of the cos, whatever is there, has to become equivalent to 1. So cos becomes maximum when omega 1 minus omega 2 by 2 of t is cos. I am just taking cos inverse of plus or minus 1. Cos becomes maximum at 0. That is cos 0 is 1 pi, 2 pi, and so on, 3 pi, and so on, right? So this is very clear that at this particular events, I will get a maximum intensity, maximum amplitude. Therefore, I will get a phenomena called waxing. I have drawn how does waxing happens in a graphical level in the previous video. Please look into that if required. Now, omega 1 minus omega 2 by 2 into t equal to 0. This implies t is also equal to 0 in first case. In the other case, next case, when it happens next is at a value of pi. So the time when it happens is 2 pi by omega 1 minus omega 2. We know omega is 2 pi into n. So omega n is omega 1 is 2 pi n1 and 2 pi n2. So that is 2 pi gets cancels 1 by n1 minus n2. So if you notice carefully, the first time it happens at a time equal to 0. Next time it happened at time of 1 by n1 minus n2. So we can say, if you continue this discussion a little further, time interval between two maximas is T1 minus T2 minus T1. If you call this as T2, if you call this as T1, that is 1 by n1 difference n2 minus 0, that is 1 by n1 difference n2. Time intervals between two maxima is also called time period of the beat. Once you figure the time period of the beat, you want bit frequency. Bit frequency is, any frequency is always reciprocal of time period, 1 by time period. That's 1 by n1 difference n2, that is n1 minus n2, or whoever is bigger, n1 difference n2. So bit frequency means how many number of the beats that occurs per second. Number of beats per second. I have found that number of beats per second as n1 difference n2, but be careful that this n1 difference n2 has to be small, it shall not be large, because if the bits difference between them is say more than 10, be careful that bits can be heard only when n1 difference n2 is less than 10 or at the 10 maximum. Why? Because there is a term called persistence of hearing. For a normal human being to hear two sounds, they need a regular gap between them. That gap is called persistence of hearing. That value is 0.1 second. That's the time interval. So the frequency reciprocal of the persistence of hearing is 1 by 0.1, that is equal to 10. Means what? If the difference between the beats becomes more than 10, they will reach our human ear at an interval that is less than 0.1 second, and you won't be able to get them, you won't be able to understand them. So beats can be developed but cannot be experienced by human being if the interval between the two sounds is less than 0.1. That means the number of the beats maximum possible is 10. That means the difference between the two frequencies has to be 10 or less than 10. We can prove the same not only with waxing, like what I have proved here. We can do that in the case of in the waning also. We can do that quickly. Let's do that. I will just go for the next line a little. For waning to happen, this value, this amplitude, has to become minimum. That means cos square of omega 1 minus omega 2 by t is minimum. Right? So minimum of that is equal to 0 for a cos function. Then omega 1 minus omega 2 by 2, and t minimum is possible at angles pi by 2, 3 pi by 2, 5 pi by 2, and so on. Right? So if I have to write when it happens first, omega 1 minus omega 2 by 2 and t happens first waning, the first waning. Minimum of the beat happens at pi by 2. So t becomes 2 pi by t of omega 1 minus omega 2. 2 pi by omega means there is another 2 pi of n1 minus n2. 1 2 pi gets cancels. So the first one happens at 1 by n1 1 by 2 times of n1 minus n2. if you derive for the next waning, yeah, second waning, for second waning to happen, one is pi by 2, the next one is 3 pi by 2. Omega 1 minus omega 2 by t is 3 pi by 2. So t will be 2 into 3 pi by 2 of omega 1 minus omega 2, that 2 can be cancelled. That is 3 pi by 2 pi of n1 minus n2, pi and pi will cancel. So this is 3 by 2 times of n1 minus n2. So if you notice carefully, the first waning happens here, 1 by 2 of n1 minus n2. The second waning happens at 3 by 2 of n1 minus n2. So what is the interval between two wannings? The gap between two wannings is 3 by 2 of n1 minus n2 minus 1 by 2 of n1 minus n2, that is 2 by 2 of n1 minus n2, that is 1 by n1 minus n2. Interval between two wannings is called time period. So I can get bit frequency as 1 by time period, that is n1 difference n2. So if you notice carefully, in the previous case also we got the number of the bits, that is bit frequency, as n1 by n2. Here also I got n1 by n2. So it doesn't make a difference whether you use waxing or wanning, or what we have to say, two waxings you can take, two wannings also we can take. Anytime you will get a same answer itself. I just want you to understand that both are same. Anyway, I have derived both of them for your convenience. That's it. Thank you for watching.